Today we're going to continue our discussion about proving similarity, and we're going to talk about some special rules for triangles. So our learning targets are I can understand special similarity relationships in triangles. That includes side-side-side similarity, angle-angle similarity, and side-angle-side similarity. It also says I can use proportions to solve problems involving similar figures. So down here we are going to start with the side-side-side triangle similarity. Also, we can abbreviate that with SSS for side-side-side. And this one says, are these triangles similar? Explain. So we've got two triangles here. And what the side-side-side triangle similarity statement says is that corresponding sides must all be proportional. And so first we have to ID which sides are corresponding. Again, sometimes having a highlighter can help if we want to highlight in different colors to kind of help us. Here we see that the smallest, shortest side, AB, corresponds to the smallest, shortest side on this shape, which is FB. So our little hint says the little side will match the little side, the medium side will match the medium side, and the longest side will match the longest side. Then I have my medium side here is BC, my medium side here is FE, and then my longest side for both shapes is AC and DE. So you can see how a highlighter might help us kind of identify and coordinate those corresponding sides. Then we have to set up our ratios for corresponding sides to see if the ratios are equivalent. So I'm going to, in this case, I'm just going to go big to small. So I'm going to go big pink is 12, little pink is 8. And I want to know, does that equal the medium-sized purple, or the biggest medium size is 15. 15 corresponds to 10. And is that equal to 18 over 12? So notice that I always listed the biggest triangle measurement first, and then I listed the corresponding side of the smaller triangle second when I set up my ratios. And now I just want to know 12 divided by 8 is 1.5. 15 divided by 10 is 1.5. And 18 divided by 12 is also 1.5. And so 1.5 equals 1.5 equals 1.5. That is true. So because all of the sides are proportional, side, 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 all three sides are proportional for both shapes, we would say that yes, these two shapes are similar, and their reasoning is because of side, side, side similarity. So down here we've got some more practice problems. I'm going to zoom in a little bit here so that we can really see what's going on these examples. It says determine whether the triangles are similar. If yes, write a similarity statement and explain your reasoning. So on this one, to identify corresponding sides, I have AB, which is my long side that makes the right angle. That corresponds with HG, the long side that makes the right angle. Then I have the short side of the right angle is, in this case, BC. In this case is GF. And then my long side, my longest side, what we call the hypotenuse. In this case, it's the side that doesn't make the right angle. I have AC and HF. So we can see that these two shapes have, or that these two triangles have the same shape. Let's see if they're actually similar or not, if they're proportional. So what I have to do is I have to decide, I'm going to do my green over green, 48 over 8, and I want to know, does that equal purple over purple, 84 over 14? And does that equal pink over pink, 72 over 12? And I'm going to pull out my calculator to help me. I know that 48 divided by 8 is 6. 84 divided by 14 is 6. And 72 divided by 12 is 6. So because 6 is equal to 6 is equal to 6, all of my sides are proportional. And so it says determine whether triangles are similar. Yes, they are similar. If yes, write a similarity statement. So triangle, in this case ABC, is similar to, I just put a little squiggly, triangle. Again, remember that order matters. So I went from my A to my B was my pink side, top to bottom, and then from B to C was my green. So I'm going to go from pink, top to bottom, HG, and then along my green side, HGF. So it's not necessarily in alphabetical order. It needs to go in order of corresponding angles. A corresponds to H in this case. B is my right angle. G is my right angle. They're both in the middle. And then C and F are my other corresponding angles here. And they both fall at the end of my list. So triangle ABC is similar to triangle HGF. That's my similarity statement. When I explain my reasoning, I would say, yes, these two shapes are similar because of side, side, side similarity. And I just abbreviate that with SSS for side, side, side similarity. And then this very last one, determine whether the triangles are similar. If yes, write a similarity statement and explain your reasoning. In this case, again, I have my long side that makes my right angle is JK. My long side here is RS. My short side that makes up my right angle is KL. My short side that makes my right angle here is ST. And my long side that is opposite of the right angle, we call hypotenuse, JL, corresponds to RT. So I highlight my corresponding sides with the same color, and then I can set up my ratios. 12 over 12, pink over pink, equals green over green, 5 over 9. And we want to know, does that equal purple over purple, 13 over 15? Right away, I see 12 over 12 is 1, and I know that 5 over 9 is not 1. In this case, it's 5 repeating, or 5/10 repeating. That's not equal. If I plugged in 13 divided by 15, I could stop there, but even if I didn't want to, I wanted to double check. 0.86 repeating. None of those ratios are equal, and so we would say that these two triangles are not similar because, so are the two triangles similar? No. It says if yes, write a similarity statement. There's no similarity statement to be made because they're not similar. We have to explain our reasoning. The reason that these two shapes are not similar is because sides are not proportional. So the bottom line here is if you know all three side lengths in both triangles, you do not need to compare angles. You can just compare sides, and if all three sides are proportional, then you have two similar triangles. It does have a little caution here. Make sure that you compare all sides for side, side, side similarity. You must set up 3 ratios, not just 2 sides, but you have to double check all 3 sides if you're going to ignore the angle measures when you do this.